So let's talk about complex fractions. Complex fractions are fractions within fractions. That's why we call them complex. This is actually the third time you guys have seen this, because you did this in Algebra 1, we did it at the beginning of the year, and now we're seeing it again. It's not as difficult as it seems.
It looks like a headache sandwich.
Okay. The first one, example 1, 7 over 2 divided by 9 over 4. It's 19 over 4. Okay. What is the part about this fraction that you really, really don't like?
There's a
That is two fractions.
There's a fraction inside of it. Let's get rid of these fractions. So circle the denominators for me. We need to get rid of those denominators. To cancel out denominators, we multiply by the least common multiple. The least common multiple is not the same as the lowest common factor. A factor is a part of a number. A multiple is the smallest number that we can multiply that number into. Okay, so looking at the 2 and the 4, if we multiply both of those by the least common multiple, because whatever you do to one side, you have to do to the other. So whatever we multiply on top, we have to multiply on bottom. If we multiply by the least common multiple, our fractions will cancel out, or our fractions will reduce. So between 2 and 4, what is the lowest common multiple?
2.
2 is a factor. 4. Because, think about it, 2 can go into 4, and 4 can go into 4, right? Can 4 go into 2? No. So it has to be 4. So multiply the top and the bottom by 4. The reason we have to multiply the top and the bottom by the same thing is because if we multiply by 4 on top and multiply by 4 on bottom, 4 over 4 reduces to what? 1. So are we actually changing the value of anything? No. Okay, so let's think about this. 2 goes into 4 twice. So we're left with 2 times 7. What's 2 times 7? 14. Over, because we still have that big fraction bar. 4 and 4 totally reduce. So what are we left with on bottom? 19. Can you reduce 14 over 19?
No.
So you're done.
That was some freaky thing you just did.
So example 2. 3 over xy divided by 7 over x squared y. So as a reminder, we are trying to get rid of these denominators by multiplying by the least common multiple. The whole goal of the least common multiple is so that everything in the denominator will reduce. So if on top I have an xy, but on bottom I have an x squared y, what would I have to multiply by? X squared y. So multiply the top and bottom by x squared y. So on top, the x's, x cancels with one of the x's, and both y's cancel, so we have 3 times x left over. So what does that give me? 3x over x squared totally cancels, and y totally cancels, which is what we wanted to happen, all over 7. 3 and 7 do not reduce, so that's your answer. So example 3, I have 1 over a divided by 2 over a plus 1. What I want you guys to do before we even start, that a plus 1 in the denominator, stick it in parentheses, because a plus 1 is its own term. It's one single term. If I tell you a number to plug in for a, you just add 1 to it and that gives you the entire term, correct? Okay, so if one denominator is just a by itself, and one of them is a plus 1, what do you think our least common multiple will be? If I multiply both sides by a, or top and bottom by just a plus 1, am I allowed to cancel out the a's? Why? Because it's attached by addition, right? This is actually whatever a is and then plus 1. So what would I have to include here in order for the a to be able to cancel? Another a. So your least common multiple is a times a plus 1. Okay? We did this when we were doing this stuff at the beginning of the year. We also revisited this when we were adding complex fractions, remember? And we had to factor the denominators and get a common denominator. So it's the same idea. So then when I'm multiplying, the a's can reduce. And a plus 1 is a complete term, so it can reduce with the entire term a plus 1. Does that make sense?
Yes.
Okay. So we have a plus 1 times a, so that's a plus 1, over a times 2, 2a. Can I reduce the a and the a here?
No,
Why?
because it's
It's
attached.
attached by addition. I guarantee at least one person is going to try and do that, so please do not let it be you.
It'll be more.
This a plus 1 is one single term, so leave your answer the way that it is. You can't reduce any more. Example 4. X plus x over y divided by 1 plus 1 over y. So these types of problems is the reason, that is blurry, is the reason why I didn't show you the dividing thing before, because eventually we would end up with distributive and FOIL, and that's a lot more work than it needs to be. One thing I do want you guys to remember, x by itself is the same as x over 1, and 1 by itself is the same as 1 over 1. You do not have to write them over 1. I'm doing it just for this first one so that we are used to the idea that the denominator here is a 1. So if my denominator here is a y, denominator here is a y, and both of these are 1s, what is the least common multiple? Y. So you are multiplying the entire numerator by y, and you are multiplying the entire denominator by y. If I have y times this whole thing, which property am I going to end up using? Distributive. We have to distribute y to everything. So what I do, so to make my reducing a little bit easier, distributive means that I multiply y by each one individually, correct? So I actually write that all out. So I multiply y by the first one and y by the second one. So I write it all out so that I don't reduce and then forget that it's there. Okay? So I multiply y by everything. I don't draw the arrows every single time, just this first time so that you guys recognize that it is distributive property. Okay? So with y times x over 1, does anything reduce there? So when we multiply, what do we get? xy. What about x over y times y? What happens there? Y is reduced, and we're left with a plus, because it's a plus right here, x. Do the denominator for me really quick. So try the denominator on your own. All right, so with the y times 1, does anything reduce there? So you should end up with just a y, yes? Okay, plus, so include the plus what? 1, because the y is reduced. How many of you boxed this and said you were done?
No.
Somebody that said no. What else can I do? Jessica, what else can I do? You don't know? Monica, what else can I do? There's a GCF in the numerator. That's an x. So pull out the x. And that leaves us with y plus 1 over y plus 1. Oh my gosh, what can I do? Reduce, and the whole answer comes out to x. Moral of the story, always double check if you can factor still, okay? Just like on that one problem on the homework, where after you were done, you could still factor, exact same thing. Always double check to make sure that you're totally done, okay? Last one like this. This is the most complicated, but it's actually not too bad. So we have 1 over a plus 1 plus 1 over a minus 1, all divided by 1 over a plus 1 minus 1 over a minus 1. It's a lot of a's and 1's. The very first thing when I look at this problem that I notice is that the top is almost identical to the bottom. So your first instinct might be to reduce the a plus 1's and reduce the A minus ones, and then it all comes out to an answer of 1. Why can I not do that? This one's attached by addition, and this one is attached by subtraction, so they are not identical. It's like saying 2 plus 4 over 2 minus 4. They're not the same thing. So we need to get rid of those denominators. In the denominator, I have an A plus 1, and I have A minus 1. So what is my least common multiple going to be? A plus 1, A minus 1. So multiply everything by that. And the reason why we're multiplying every single term by the LCM, or least common multiple, is because of the distributive property. I'm just skipping the step of drawing the arrows. But we're multiplying everything by the same multiple. Equals. Okay, let's do this piece by piece. A plus 1 times A minus 1 times 1 over A plus 1. The A plus 1's reduced, so we're left with A minus 1. Please keep it in parentheses for right now. Plus, what reduces here? A minus 1. Oops, I did 2 A plus 1. A minus 1. So 1 times A plus 1 leaves me with A plus 1. Also keep it in parentheses for now. All over. A plus 1's reduced here, so that's A minus 1. Minus. A minus 1's reduced, so we're left with A plus 1. Is everybody with me so far? Okay. Can I cancel out the A plus 1s and the A minus 1s?
Yes. No.
This one's attached by addition, and this one is attached by subtraction. It's the exact same reason why we couldn't do it at the beginning of the problem. So, what else do you guys see that we possibly could do? Distribute the negative and distribute the positive. Remember, when you distribute, the parentheses all go away. Some of you still, after you distribute, change these to multiplication problems. These are two things being added. So after we distribute the sign, we can take the parentheses down. So this is going to be A minus 1. Addition doesn't change the signs of anything, so it's going to stay as plus A plus 1 over A minus 1 minus A minus 1. Let's combine like terms. On top, A plus A, what's that give me? 2A. Negative 1 plus 1. 0, so they totally cancel, right? All over A minus A cancels at 0. Negative 1 minus 1. Negative 2. Can I do anything else? Yes, I can reduce the 2 and the negative 2. What's 2 divided by negative 2? Negative 1. So the whole thing comes out to negative A. Okay. Not the same as 1, right? Unless A equals negative 1. But let's not even get into that. Okay, so the last thing we're going to talk about right now is special triangles. There were two types of special triangles, 30, 60, 90s and 45, 45, 90s. That has to do with the angle measures. I'm going to zoom in on this so that you guys can see just the special ones a little bit closer. So the special triangles, the angle that is 30 degrees, we always call the opposite side length A, and then we can tell using just that the different side lengths of the other pieces of the triangle. So the angle opposite of 30 is always called A. So the one opposite of 60 degrees is always called A root 3 or root 3 times A. It's the same thing. Okay, so A root 3 or root 3 times A. So whatever A is, we multiply it by root 3. Okay, if A is root 3, it would be root 3 times root 3. Does that make sense? So whatever A is opposite of the 30 degrees, we plug it in here. The hypotenuse of a 30, 60, 90 is always 2 times A. So whatever A is, you multiply it by 2, and that's always the hypotenuse. It will either be given to you, or a different side will be given to you, and you can problem solve to get A. So A will either be given to you, or a different side length will be given to you. They will never say, this is a 30, 60, 90, no side length, figure it out, because it's impossible. You can't do that. Okay? So, a 45, 45, 90 is a little bit different. If we have a 45, 45, 90, that means our two, and this picture is not a very good one, our two angles are the same, which makes this what type of triangle? Do you guys remember the name? Isosceles, meaning the two base angles are the same length, which also means that the two sides are the same length. That's why this is not a great picture. Since a 45, 45, 90 triangle is isosceles, the two side lengths are the same length. If we went through Pythagorean theorem and solved for the hypotenuse, it would always come out to A times root 2. Okay, so whatever A is, multiply it by root 2, and that's your hypotenuse for a 45, 45, 90. So we are going to do one problem using this. Okay. So the triangle for the last example that we're going to do, we have triangle ABC. The 30 degree angle is at angle A, and the opposite leg to that is 4. So if we know that this angle is 30 degrees, we know that angle B has to be 60. I want you guys to try and fill out the other two side lengths on your own. So give me the other side length and the hypotenuse using a 30, 60, 90 triangle. Okay, so the side length across from the 30 degrees, that's our A, right? And we know that it's 4. I gave it to you. So what would AC be? 4 root 3. So we just take A and multiply it by root 3. The hypotenuse we said on our generic triangle is 2A, so what would AB be? 8. Okay, so you should have all of the sides of the triangle labeled. So the very last thing we're going to do is we're going to find the sine of the 60 degree angle, the cosine of the 60 degree angle, and the tangent of the 60 degree angle. So let's write that down. So the sine of the 60 degrees, the cosine of the 60 degrees, and the tangent of the 60 degrees. Okay, guys, let's just fill in first what each of these are. Sine is what over what? Opposite over hypotenuse. Cosine is what over what? Adjacent over hypotenuse. And tangent, my favorite one, is opposite over adjacent. Okay, sine of 60 degrees. So we're actually looking at this angle right here. The side that is opposite of that 60 degrees is 4 root 3. So that's what we're going to plug in. Over the hypotenuse, which is 8. I can reduce that. 4 goes into 8 2 times. So my sine is root 3 over 2. And that's your answer for the sine. Do cosine and tangent for me really quick. So for cosine of 60, I had 4 over 8, which does not reduce to 2. It reduces to 1/2. So please do not give me 4 over 8 and then say that it's equal to 2. She's here. Thank you. And then tangent, opposite over adjacent, 4 root 3 over 4, but the 4 is reduced, so the whole thing comes out to root 3. Who got both of those correct? How do you guys feel about all of this? Fabulous. Okay, that is 13.3.